Hey physics fans, I know some people have been having some trouble with these angled shots problems. They do get a little tricky. So I thought I'd walk through a couple of them on the projectile practice worksheet so that you can kind of see my thought process as I go through it. So this is number 5 on that second part, the angled shots portion of the worksheet. And it says a grasshopper hops and reaches a vertical height of 3 meters and jumps a distance of 5 meters. So the first thing I'm going to do is draw that situation out. So I know my distance in x is 5 meters, my distance in y is 3 meters. And I kind of show the direction that that grasshopper is going. In this case, the grasshopper is represented by a circle because I was a little lazy this time. Pretty pictures next time. So then part A says, what was the initial vertical velocity of the grasshopper? Well, the first thing I'm going to do, like I've always been doing, is make my table. So I'm going to make my table with my horizontal values, that's in the x direction, and my vertical values, that's in the y direction. So I'm going to fill in all the information that I know so that I can figure out that initial vertical velocity. So on the horizontal side, I know my distance, but that's the only thing I know so far. On the vertical side, I know my distance in y, and if we look at only going up, we look at only the up portion, so let me specify only the up portion, then we know that the final velocity is going to be 0 meters per second because we know at the top of that path our velocity is 0. So we know our distance, we know our final velocity, and we know our acceleration. It's negative 9.8 meters per second squared because this grasshopper is in free fall. And then initial velocity and time we don't know yet. Okay, great. So next part is figuring out that initial velocity in y. Well, if we look at our vertical section over here, we can see that we have 3 knowns, our distance in y, our final velocity, and our acceleration. So I need to find, one second here, I don't know how this works. Trying to change the colors. There we go. Okay. So we need to find an equation from our kinematics equations that involves these 4 variables that I've highlighted. So I look at my equation list and I've picked this one out. So this is the only one that does not involve time and that has all of our knowns and our one unknown. So I go ahead and plug in all my values and I'm going to solve the equation for our initial velocity in y. Okay, so far I've gotten initial velocity in y squared is equal to 58.8 meters squared over second squared. So I'm not done yet. Last step is taking the square root of both sides, and that gives me my initial velocity in the y direction. 7.7 meters per second. Great, first part done. B asks, what was the horizontal velocity of the grasshopper? So if I look at my horizontal side over here, we see we don't have enough information yet to find that velocity in x. I know my distance, but I need my time if I'm going to figure out the velocity in x. So the first thing I do is find the time. And I can do that by using the vertical side again. Because on the vertical side, we know the time here is going to be the same as the time in horizontal. So I'm going to find an equation that's going to work. This is the easiest one. So I've only got my one unknown and 3 knowns. I'll plug in all my values and solve for t. Okay. Now this t that I found is only the time up, because remember, I'm only looking at the up path of the grasshopper, so only to the peak, because we use a final velocity of 0. So this is half of the total time. So to get my total time, I'm then going to multiply that number by 2. So I get 1.57 seconds. So that's step one of part B. I found my time. Now that I know my time, I can go back and I can solve for my velocity in x. And remember, we only use this one equation for the horizontal, vx equals dx over t. Plug in my values, 5 meters over 1.57 seconds gives me 3.2 meters per second. Awesome. So I've now found the components of my initial velocity. So I'm going to draw that out now. So my vertical component is 7.7 meters per second, and my horizontal component is 3.2 meters per second. Part C asks me to add these vectorially to get the initial velocity and angle the grasshopper hopped at. Now don't get confused by the vocabulary used here. All you're doing is looking at this triangle and finding that hypotenuse value, so the initial velocity here. To do that, I use the Pythagorean theorem. So here I've written it c squared equals b squared, or a squared plus b squared. It's just my hypotenuse squared is equal to the two sides squared and added together, the two legs. So I'm going to go ahead and solve that for my initial velocity, and I get 8.3 meters per second. So now I know that this guy right here, oops, try that again. This guy right here is, what did I say, 8.3 meters per second. Great. But it also asks me to find the angle that the grasshopper hops at. So to find the angle, I'm going to use the two values that I started with, my 7.7 and my 3.2, and I'm going to set up my trigonometric equation here for the inverse tangent of 7.7 over 3.2, because we know, hold on a second here. Alright, I was working a little too fast there. It's just the tangent, not the inverse tangent there. So it's the tangent of theta is equal to 7.7 over 3.2. But then to get my value for theta, or the angle, I have to divide 7.7 by 3.2, then take the inverse tangent of that number. So the tangent of the angle, theta, is equal to the opposite side over the adjacent side, and then we can find our theta, 67.4 degrees. There we go, problem done. Let's try the next one. So number 6, wearing really short shorts, a long jumper jumps with an initial velocity of 8 meters per second at an angle of 40 degrees above the horizontal. So I went ahead and I drew that first part, and then, as usual, I'm going to break this down into its components. So remember, whenever we're given an initial velocity at some angle, we're talking about the hypotenuse. So here I found this leg here, the distance in x, and I know that that's the cosine of 40 times my hypotenuse, or the way I've set it up is the cosine of 40 is equal to Vx over 8 meters per second. I solve for the velocity in x, and I get 6.1 meters per second. I'm going to do the same thing for the vertical part. And in that case, it's sine of 40 degrees because we're looking at the opposite side of the angle instead of adjacent. And we get 5.1 meters per second there. Then I'm going to set up my table, just like I did above, with my horizontal and my vertical knowns and unknowns. So I'll fill those in. For the horizontal, I know my velocity this time. I don't know my distance, and I don't know my time. For vertical, I know my velocity, right? I just solved for it. And I know my final velocity, again, because we're going to be looking just at the up part of the trajectory. We know the acceleration, as always, negative 9.8 meters per second squared. And then we don't know yet the distance or the time. So part A asks, how far is the jumper's jump? Well, do we have enough information here to find this? Looking at the horizontal, we see that we know just one of our values there. So it's going to be a little difficult to get our distance just by looking at that. So we're going to have to look at our vertical part. And again, we need our time first. Once we have that time, we can solve for our distance in x. So, looking at my vertical, I know my initial velocity in y, I know my final velocity in y, I know the acceleration, and I'm looking for time. So I'm going to pick one of my kinematics equations that has those 4 variables in it. So everything but distance. So the one that works for me is this one here. And I'm going to go ahead, plug in my values, and solve for my time. So for time, I get 0.52 seconds, but remember that's the time that it takes to go up to the peak. To get my total time, I need to double that. So my total time then is 1.04 seconds. That's the time I'm going to use for the horizontal distance. So now I've got my time and my velocity in x, so I can solve for distance in x. I set up my horizontal equation, vx equals dx over t, and I solve for my distance in x. It's 6.4 meters. Now on to part B. Part B, we're trying to find the distance in y. Again, looking at the vertical side, we know everything now because we found the time. We know acceleration, we know final velocity, we know initial velocity, we know everything but the distance in y. So I can pick any of those equations that has distance in them, any of the kinematics equations. So I'm going to pick this one here. To me it seems like the easiest one. I'm going to plug in my values and solve for distance in y. I get distance in y is 1.33 meters. And there you go. So I hope that those 2 examples were helpful for you. If you're still having trouble with these, you still have questions, please come in and see me. But hopefully this gives you a good idea of the steps that you have to walk through for these kinds of problems. Good luck!